In this problem, we're going to use the law of sines to determine if this triangle has one solution, no solutions, or two solutions. So we're given one fixed angle. Angle C is fixed. Angle B, we don't know what that angle is, and we don't know the length of B. So, in other words, this guy could be angled, well, we know the length of it, but we don't know, let's see, I guess I'll describe the line. We don't know if it's like this or like this. We don't know the angle of B. We just know that length. And the other thing we don't know is this side B. We don't know if it's short or if it's long. Maybe it's too short to reach that side. We don't know that length. So those two are kind of up in the air. But we do have these other two fixed sides. Side A and side C are fixed, and angle C is fixed. So we can use the law of sines, and the only ratio that we have to start with is C. So we start with C. So we have angle C and side C. And so we have sine of 62 degrees over 2.6 times 10 to the 25th degrees is going to be equal to any ratio of any other side. We don't have any information at all about B. So we have to use A. To find angle A, we start with this side. So we get sine of angle A over 2.9 times 10 to the 25th. Then to solve for A, when I cross multiply, I get 2.9 times 10 to the 25th times sine of 62 degrees. And then to get sine of A by itself, I divide by 2.6 times 10 to the 25th. So when I cross multiply and solve for sine of A, I get that. So that, and now I take the sine inverse of both of those sides. And I get A. At this point, I have to approximate. So I'm going to use the calculator to get this number. Let's see. Let's see here. We have 2.9 times 10 to the power of 25, close that parenthesis, times sine, make sure I'm in degrees, which I am. It's not written up here, but you can see my button is radians, so I'm in degrees. Sine of 62 degrees, close that parentheses, and divide by 2.6, I'm going to put parentheses around that one, 2.6 times 10 to the 25th, and two parentheses there. And I get that, I'm sorry, that's sine of A. I need to get sine inverse of that. So I'm going to stick a sine inverse in front of all this. And close that parentheses, and then I get 80. So my A could be 80 degrees is one possible solution. Okay, I'll round to the nearest tenths. So if A is 80 degrees, then that means this must look like something like that. Okay, so my C is, I won't mess with that. All right, so to solve for that, now I can solve for that B though, the side B. And to do that, so actually A has two options. So that is one option. I'll go ahead and put that in blue. But there's another option that doesn't come out from, there's a second solution here. which I will put in, let's say, I don't know, green. And it is a supplement to this. So 180 minus 80 for that obtuse angle. That is, so angle A might be that guy. So let's see. Make this a little bigger so I can write in here. So I might have this 80-degree angle, or I might have its supplement, which would be 180 minus 80. So this might be, oh, that doesn't look like a 100-degree angle, does it? So it might be this guy right here, which is a 100-degree angle. So it's supplement. That 62 is kind of in my way. That 62 goes to the angle C, and I'm trying to draw this green angle as an option for angle B. So there's two options for angle B, either the 80 degrees, whoops, sorry, that should be a B, or the 100 degrees. Okay, so we gotta look at both those options. Oops, I mean A, I'm sorry. That should be an A. Okay, so I just kind of moved the 62 out to see that it's angle C, that little black one over there. This little guy is 62. So you can see that angle A is either going to be that 80-degree angle or that 100-degree angle. Okay, so A is either 80 or 100 minus 80, which is the green one, which is A approximately equal to 100 degrees. So let's assume that we have the situation with the blue. So we have the blue triangle, so that looks like this. We have that 80-degree angle at A. If A is an 80-degree angle, then angle B must be using that triangle sum theorem. We have 180 degrees minus the 80-degree angle A minus the 60-degree angle C, which gives us a 38-degree angle for angle B. And that gives us angle B has a side then using the sine law of sines. We have sine of 38 to side B equals sine of 62 to side C, which is 2.6 times 10 to the 25th. So then I can solve for B. I'll do equal sign first to do the exact value. I'll cross multiply to get the 2.6 times 10 to the 25th times sine of 38 divided by sine of 62. When I cross multiply and then divide by solve for B, I get that. I will be happy with that number because that's an exact number. But in order to check my answers with the back of the book, I will go ahead and use a calculator to get that estimated value. So that is, let's see. Let's use parentheses, 2.6 times 10, whoops, that's a 1, 10 to the power of 25, close the exponent parentheses, times the sine of 38, close the numerator, close sine, close the numerator parentheses, all of that divided by parenthesis for the denominator, I'm going to do sine of 62. I say when you're in doubt, put an extra parenthesis in, it never hurts. Well, I mean, if you put it in wrong, it would hurt, obviously, but when in doubt, put it in. Better too many than not enough. Which leaves me with a B side of 1.8 times 10 to the 25th. That's what this E plus 25 means? It means times 10 to the 25th. It means move the decimal over 25 times. So it's a really, really, really big number. Excuse me. All right, so that's one of our options for our, we got all our angles and all our sides. Okay, now let's go over to this other option. What if the angle was actually 100 degrees? Then I end up with B would be equal to 180 minus the angle, oops, sorry, wrong one, minus the angle A, minus angle C, which gives me 18 degrees, right? Yeah. And then I still have the same side C ratio, so I'll go ahead and just write that again. I forgot the degrees over here. I'll stick those in. 2.6 times 10 to the 25th for side C, angle C, and then angle B ratio is that, and that gives me side B of, let's see, cross multiply, and then solve for B, and I get this. Looks like I forgot my degrees again. Okay. And then that's my exact answer. And as an approximate answer, let's see what I can get. Whoa. What's going on? I get 2.6 times 10 to the power of 25, close the exponent, times sine of 18, close the sign, divided by sine of 62, and I get a possible B side of 9.09. Let's just call that 9.1 times 10 to the 24th. So you can see that matches our triangle. The green side is a little shorter. So the green triangle option has this obtuse angle A. So side B will be shorter. Angle B will be smaller. It's only 18 degrees now. So there's our two possible solutions.